We are ready for lesson 2.4. 2.4 is dealing with the idea of finding a percent of a number. So hopefully you've noticed on the board that I've asked you to have your packet because we're going to do some highlighting in our packet so that we can always go back to it and remember what a couple of these key words actually mean. We'll use these keywords from this point forward, and you'll use them for many years to come when it comes to mathematics. So when I look at the I can statement, then once again, it's going to tell us what our goal is, what our objective is for this particular lesson. And it's the idea that I want to be able to find a percentage of a number. Now, they give you all of this other information, and I don't need all of this other information because they're going to give me several examples and several different approaches and different ways to do the exact same math problem. What I want you to see is that we have one way, one pattern, one set of questions that I can ask no matter what the setup of the problem to be able to solve these questions. So if I can learn that pattern, then I'm going to be good. Well, let's start with this page of our math packet. These are the words of math that we use and are often going to appear in our story problems or in our actual math problems themselves. And there are two of them that I want you to highlight today. So the first one we're going to look at is the idea of the multiplication sign. And notice that word of. I want you to highlight that word of, and then I want you to add a note out to the side. And that note out to the side is that about 85% of the time that of is in a math problem, it means to multiply. Right? Now, that doesn't mean that I can't use the word of and it not mean just the word of, right? But most of the time, if it's saying this of another number or another set of information, then it's going to imply that I'm multiplying. The other word that I want you to highlight is the word is. And when I see is, then that's indicating that we're talking about an equal amount. What is this equal to? All right, so this is 27. So those two words we're going to be looking at multiple times today and changing from the words into the symbols so I can do my math. Also, as we're going through this lesson, then we have some key ideas that we need to write down. So on your first page, on page 103, I want you to write two key ideas, key pieces of information that you need to know to be successful in mathematics when it comes to percentages. The first one is that I can no way and no how use a percentage in a math problem. Make sure you pause the video if you need to, and then restart, but have this note written down. I can never, no way, and no how use a percentage in a math problem. So then we're not really sure what we're doing with this math problem, right? Because I said this whole entire math problem was finding percent of numbers. Well, it's the idea that I can't use a percentage in a math problem. However, I know how to change my percentage. So that's the second note. As I said, I want you to write down two. So your second note is that you must change your percentage. Right? Now, some of you'll get further along in school and you'll like fractions more than you like decimals. But in every one of these examples, I'm going to use it as a decimal because it's easier to use and I don't have to worry about denominators and cross reducing and all of that. So we're going to change it into a decimal, in which then I simply have to multiply because it's going to say of. All right, we have that. If you don't have it written down, don't go on. Pause it, write it down, and then let's continue. As I'm looking at these problems then, they're going to give me all sorts of information and things that I can look at. So what we're talking about is this 50 people were surveyed and asked to vote on their favorite flavor of sherbet. The results are shown in the table. So here we have the flavors, here we have the percentages. We know the total is out of 50, and out of our percentages, they want us to solve what it is that we're looking at. So let's remember that I cannot use a percentage because that's what this number is in a math problem. And if I can't use a percentage in a math problem, then I have to be able to change it into a decimal. Once I've changed it into a decimal, then I can do the math. Now they're saying if I use this bar diagram that I can come up with the answer, and I don't disagree. This is correct math. This is a lot more work than I need you to know. I need you to know a process and a systematic way of doing this that you can do over and over and over again. So as we're going through this and I look at what the problem is saying, and this is what the problem is focused in on. They're telling us that 20% of 50 is 10. They're showing you with that bar down below. Well, I want you to write down in your notes, either on the side or on a note card or on your notebook paper. I want you to write down these 3 steps, because these 3 steps are the ones that we're going to repeat over and over and over again anytime that we are doing a percentage of a certain number. Step number 1, I'm going to change my percent into a decimal. That's going to be my first step. So when I look at these 2 key ideas, and I know I can't use a percent in a math problem, so I'm going to change my percent into a decimal, that has to be step 1. When I look at the decimal they're talking about, 20%, then I know my steps now are that I drop my percent sign. If there's not a decimal, I add a decimal at the end of the whole number, and now I move it just from right to left 2 times. Once again, always 2 times, and never anything but 2 times. My second step will always be, I'm going to know that of means to multiply. And if I know that of means to multiply, I'm just going to make of a multiplication sign. And then my third step is the word is that we highlighted in our packet. So is means equal. So then instead of having the word is, I'm going to make it an equal sign. And what I've done now is I've taken all my words and all my information, and I've just simply created a math problem. My math problem, if I get rid of all the marks, simply looks like 0.2 or 2/10 times 50. When I do that math, then I like to stack the one with the most digits on top. Often on these, it's going to be the whole number that we're trying to find the percentage of. So I have 50 times 0.2. When I multiply those, 2 times 0 is 0, and 2 times 5 is 10. Once again, when there's a decimal in my math problem, we don't need to freak out and we don't need to move that decimal. We simply need to do the math when it comes to multiplication. Our next unit that we get into is dealing with decimals, right? So as I've already told you when I worked with you, then adding and subtracting, I want to bring down my decimal. Dividing, if it's inside the box, I'm going to bring it up. But multiplying, I don't do anything with until I do the math. So if I do 2 times 0 and 2 times 5, I get 100. However, I have 1 decimal position, not decimal points. I have 1 decimal position in my math problem. So I'm going to move my decimal from right to left 1 time, and my answer is 10, which is exactly what they told me here. So I'm just proving to you that the bar method they're showing you down below can be done by following these steps, and we're going to do those steps each and every problem that we have. Here's another way that they're showing you that you can set it up. You can do the equivalent ratio tables, and you can figure out, because if you have the 50 and you have 10, then you end up with the 120. It's still going to be done the exact same way, though. If I simply follow those steps, then once again, I have the same math. 20% of 50 is still going to get me to the same answer. So if I do it with the bar table, if I do it with the equivalent ratio table, it's just extra work that I don't need you to do. If you just simply follow these 3 steps, you set it up, you're still going to get to the same answer of 10. Notice we get 10 when we do our math, and they're telling us that n is equal to 10. So let's practice our problems. Oh, I forgot that they're doing this one also. So when I do the double number line, so they've created this double number line. Once again, it's comparing 2 things on a number line and showing what the equivalent number is between the top and the bottom. It's just a lot of work. There's nothing wrong with that process. It is a sound mathematical process. It's just more work than you need to do. What I need you to be able to do is simply to follow the steps and do the math, right? They're telling us that 20 is corresponding to 10, and we know if we follow those 3 steps to find out that what 20% of 10 is, and we get 10, it's the same answer, right? So I can check and prove my answer multiple different ways. All right, so now we're going to get into the practice problems that they've given us. So the first example, they give us this pie chart, and we have to be able to identify the information that it's given and use the information that's provided in the setup. It says the graph shows the types of snacks that students at York Middle School bring with them to school. Suppose there are 300 students at the school. All right, so I know there's 300 students. That's all my information that I really have at this part, other than I know we're talking about snacks, and here's a variety of snacks. The question, how many of them bring cheese? Cheese. No snack, poor kids. Chips, cookies, oh, cheese. Cheese is right here. So that's 15%. So what we're being asked to do then is, if we're talking about 15%, 15% of what? Well, 15% of the 300. So we're going to follow our steps, right? So if I know that I'm finding 15%, the cheese, of the 300 students that they're mentioning, I'm going to follow my 3 steps. I'm going to set up my math problem. Right? So if I set it up and I have 15%, I know my first thing is to change my percentage into a decimal. So when I drop my percent sign, I know the decimal point's not there, so it has to go right behind my whole number. I'm simply going to move it from right to left 2 times. Once again, always 2 times, never more and never less. That gives me a decimal point of 0.15 or 15 hundredths. My second step is that I know that of means multiplication. And my third step is I know that is means equals to. Now I have a math problem that I can do. 15 hundredths times 300. I'm going to put my 300 on top. It's my whole number. What I'm finding, I'm multiplying it by 0.15 or 15 hundredths. Once again, ignore the decimal point. Pretend it's not even there. Just simply multiply first. So I always start in my bottom right, and I'm going to multiply with my 5. So 5 times 0 is 0. 5 times 0 is 0. 5 times 3 is 15. Now, when I have multiple digits, then this is the way that I was talking about the other day. And I always ask myself the same questions. I always say the same thing. And I always mark up my multiplication problems so I can remember to bring down my 0. I'm 51 years old and I have a math degree. I still do this process because I know it's a way to be successful, especially with those that we have struggles with focusing our mind and we have to skip steps every once in a while. So I'm going to say that my second number, and I underline it because that's my next one that I'm going to multiply with, tells me 2. And however many spaces there are behind it, I'm going to circle them so I know how many zeros, which is why it's a circle, I'm going to bring down. So my second number tells me to bring down, and then I circled 1 digit, so I bring down 1 0. Now I can multiply with my 1. So I have 1 times 0, which is 0, 1 times 0, which is 0, and 1 times 3, which is 3. Once I've done my multiplication with all of my digits down here, I simply add them together. I have zeros, zeros, and then 5 and a 4. Once again, when I get to my answer, then I count my decimal spaces because it is a multiplication of decimal problems. It's the only time I worry about that decimal. I have 2 decimal spaces behind it, so I bring it down and I go from right to left 2 times and insert my decimal. Since there's nothing behind it, I'm just going to use my whole number. If there was something behind the decimal, then I would keep those place value, but I just keep it as a whole number. And I know I'm talking about 45. 45 what? Well, I'm talking about 45 students. You can be specific and say 45 students bring cheese snacks. That's fine with me, as long as I know that I'm not talking about 45 vehicles. I need to know I'm talking about students. All right, so let's look at this one. You're going to be doing the check on your own here in a couple minutes, but I want to practice a few. So it says approximately 11% of the U.S. population is left-handed. If there are 700 students at a middle school, about how many of them are expected to be left-handed? So I'm going to walk you through the process that I go through when I'm thinking about what the math problem is saying. Right? So my first thing I do is I underline the 11% because I know we're finding a percentage of a whole number. And then they give me 700 students. But when I look at what the sentence is saying, it says that I have 11% of the U.S. population, right? So if I go through those steps and I think about 11%, then I know I have to change my 11% into a decimal. So I drop my percent sign, I put my decimal at the end of the whole number, and then I move it from right to left 2 times and add my decimal point. So I know that 11% is the same as 11 hundredths. And of, once again, tells me that I'm multiplying. But it says of the US population. Well, what they're saying is if in general that about 11% of the US population is left-handed, then if we take a toll in a building where there are 700 students, we're just going to count that as our population. So that information is telling me to take that 700 and plug it in for population. So I have 0.11 or 11 hundredths times the 700 that they mentioned, and then I see the word is. Is what? Well, is equal to, and what that answer is, I don't know. So that becomes my math problem. We know that when we get done, we'll have students that are left-handed. So when I write out my problem then, and I know that I have 0.11, and I have times 700, I put my bigger number, my 700, on top. Then I multiply by my ones. I always, once again, start in my bottom right. So 1 times 0 is 0, 1 times 0 is 0, 1 times 7 is 7. Once again, the saying that I teach with is that my second number tells me 2, so I circle it, bring down, and then I count how many I circled. I circled 1, so I'm going to bring down 1 0. The second number tells me to bring down 1 0. Now I can multiply with my second number. So I have 1 times 0 again, 1 times 0, 1 times 7. When I have them stacked up nice and neat, then all I have to do is add them, and I have zeros, zeros, 7, and 7. But once again, I'm not done. It's a multiplication with decimal points. So I go back to my original math problem. I find how many decimal points. I could have 2 decimal points, right? I could have one in the top and bottom, and then I'd have to count all of those decimal positions. But in the math we're doing today, we just have 1 decimal number. So I find the decimal point and I count those decimal spaces, and I have 2. So I go down to my answer, and I always start from the right, and I move left however many decimal spaces I have. So I move it over twice. Once again, it's a whole number. If there was a digit back here, I would keep my decimal positions, but there's not. So I'm just going to keep it as a whole number of 77. 77 would be my answer. 77 is not my answer, right? So if I have a numerical answer and it's a story problem, then I have to have a label. Now, 77 students is perfectly fine, full credit, right? If you want to be real specific, and some of you are, and I don't mind that at all because I know that you know exactly what we're talking about, but you could put 77 students are left-handed. I don't require the left-handed though, right? Don't put 77 left-handed. Reason being because there are left-handed scissors. So I might believe that you're talking about left-handed scissors. And that's not what we're talking about, right? We're talking about students. Then left-handed would be the adjective we're referring to. All right, so let's look at this problem then. Notice we have 30% of 240. Well, some of you, when you see 240, you get a little panic, or the 240, you get a little panic because we're getting into bigger numbers. Just simply follow the steps and we're going to be okay. So I make my percentage into a decimal, right? I don't need a story problem and a different setup. I'm simply going to follow the same process each and every time. So I drop my percent, add my decimal, and now I'm going to move it 2 times to the left and put it in front. Now that's 30%. I don't need to put multiplied by 30, but I can. It just gives me an extra line that I have to multiply by. In my decimals, I don't need that 0 at the end because it really doesn't change it any. If it was money, then I'd have to keep the 0. Since it's just a decimal, I can drop it off, and then I only have to multiply by 1 digit in my bottom number. If I had the 0, then I would have to do a whole line of zeros, and then talking about my second number tells me to bring down the 0 and then multiply it by my 3's. So my advice is, if it has a 0 at the end of my percentage, or my decimal, excuse me, just drop off that 0, and it's going to eliminate a step that you have to multiply. So now I have 240 multiplied by 0.3. Once again, I ignore the decimal point. Multiply by 3. 3 times 0 is 0. 3 times 4 is 12. So I put down my 2. I carry my 1. I like to show that I'm adding 1, right? It's just that little fraction of a second by putting that little addition sign, because I have had students in the past that when they just carry a 1, then their mind kind of gets sidetracked and they do 3 times 12. That's going to give you a really wrong answer. All right. So if I do 3 times 2, which is 6, and then I add 1, then I get 7. Now I look, I have 1 decimal position, so I simply move it 1 time from right to left. I once again have a whole number, so I just simply have an answer of 72. Since it's simply a math problem, I don't have to have a label. So I just circle my 72. All right, so now let's look at 70%. Same idea, right? Notice it's a 70%, and we've got to change it and what's going to be in the last position and how I can make that problem easier. So I want you to try this on your own. Pause the video, work it out, come back and check your work. If you don't have enough room to work the problem on your paper, that's fine. You can use the notes section over to the side, or you can get some extra paper. But please try it. That way I know if you need help or not. All right, so hopefully you have an answer. You have your steps, because I'm going to tell you when you're done, if you didn't get to the right answer, you don't see why you didn't get to the right answer, to raise your hand or let me know and come to me. So hopefully your first step was simply just to recognize what the math problem was, which is 70% of 580, and then you went through your 3 steps. You took your 70%. First step is to change it into a decimal. So you dropped your percent sign, put your decimal at the end of the 70, moved it 2 times to the left. When you did that, as I tried to hint, to make your life easier, just drop that 0 off, because it does not change the value at all. It's just going to be 0.7 or 7/10. Then when you set up your math problem, you have 580 times 0.7 or 7/10. I ignore the decimal at first. I'm just going to multiply by 7. So 7 times 0, you should have gotten a 0. 7 times 8, you should have gotten 56. You write down your 6, carry your plus 5. And then 7 times 5 is 35. Plus 5 gave you 40. And then you went back and you're like, well, I have 1 decimal position, so I moved from right to left 1 time. So I got an answer of 406. Right? So if that's the answer that you got and you're good to go, move on. If you didn't get 406 and you didn't figure out where you messed up in the steps on which I'm showing, please let me know. Right? I don't want you to move on and be confused with what we're doing. And it's not about getting the notes, it's about learning the lesson. Now we can move on. Excuse me. All right, so now this one, please don't freak out on me, right? Because usually what happens, the very first time we do percentages and we start doing math with percentages and people see more than 100%, they get all freaked out and they don't know what to do. So here's what I'm going to tell you to do. Do the math I just taught you how to do. It doesn't change. My math stays the same. I still have my same 3 steps, and I'm still going to follow my same 3 steps, and I want to do my math. So if I know I have 145%, I don't care if I have 15 digits there. I simply look at my percent sign, I drop it off, and I put my decimal at the end of the number, and I move it from right to left 2 times. It's the same process every time. So instead of having just a 1 or 2 digit number to multiply by, yes, I have a 3-digit number to multiply by. It's okay, right? It doesn't change the math. So when I have 320 times 1.45 or 1 45 hundredths, then I still do the same steps every time until I run out of digits down here below. I always start at the right, and then I'll go to my second number, then I'll go to my third number. So starting at the right, I have 5 times 0, which is 0. 5 times 2, which is 10. So I put down my 0, and I carry my addition of 1. 5 times 3 is 15 plus 1. That's going to give me 16. Now, I've used my 5, so now I'm going to go to my second number. And it's going to tell me to bring down 1 0. Once I've brought down that 0, then I can multiply by my second number. 4 times 0 is 0. 4 times 2 is 8. And 4 times 3 is 12. But now I have a third number. So I go to my third number. Once again, I circle however many spaces are behind it, and I have 2. So my third number tells me to bring down 2 zeros. When I bring down my 2 zeros, then I simply multiply by my third number. 1 times 0 is 0, 1 times 2 is 2, and 1 times 3 is 3. Notice they're all nice and evenly lined up. That's one of the reasons that I type these in. I'm simply now going to add. So my first column I have zeros, second column I have zeros, third column I have 8 plus 6. 8 plus 6 is 14, so I put down my 4. I carry my addition of 1. 2 is 4 plus 1 and 1, that gives me 6. 3 plus 1 is 4. I look back at my math problem. I have 2 decimal positions, so I'm going to simply move my decimal point from left or from right to left 2 times. It's still just a whole number. I don't have anything in my decimal positions, so my answer is 464. We have that. All right. I want you to try this one on your own. Same thing. Please pause the video, work it out, follow the steps, and then replay it, and let's see how you did. So hopefully you've done as I asked, and you now have an answer. So the first step you should have done is to change your percentage into a decimal. So yeah, 275%. It doesn't matter how many digits there are, same process. I drop my percent sign, I move my decimal from the end, from right to left 2 times, and now I have 2.75 times 4. Now up to this point, we have taken the number that we're multiplying by and putting it on top, right? This can be done mathematically, but it really kind of freaks people out when they see that. So if that's the case, please don't stress and worry about it. Just know that in multiplication, I can move those at any time. Addition can be done in any order, multiplication can be done in any order. So just don't set it up that way. Put it to where the 2.75 is on top. That's okay, it doesn't change my math. So I multiply by my 4. 4 times 5 is 20. I put down my 0 and I carry my addition of 2. Then I have 4 times 7, which is 28, plus 2, which is 30. I carry my addition of 3. And then 4 times 2, which is 8, plus 3 gives me 11. I go and I look at my multiplication problem. Doesn't matter that they're in the top number now. I still have 2 decimal positions. So I'm going to go to the bottom and move from right to left 2 times. I end up with a whole number of 11. All right? So if you got it, then you're ready to move on. If you didn't get it, once again, please raise your hand and ask me questions. I'm here to help you, and I love helping and trying to build you into a better mathematician. Just give me the chance, and you'll find out I can really make it much easier for you. All right, so your assignment is the same for everyone. So on page 111, you're going to do all 9 questions. On the back, I only want you to do 2 of them. I want you to do 10 and I want you to do 13. I am aware that on 13, it already gives you the answer in the back of the book. I want you to show your work and prove the answer that's in the back of the book. In the same way, on the front, 1, 3, 5, 7, and 9, the answers are in the back of the book. But some of you on the last 2 assignments, you've just written down the right answers and then you missed them because you didn't show me any work. I know the book gives you the answers. I want to see your work so you know how to do it. Start with the odds, check your work, and then if you're not getting them correct, please ask me, ask Mrs. Bloss, ask Mrs. Gallagher. We're here to help you. All right, so now you have plenty of time still to get your assignment done. There's still another 15 minutes left in class, and you're more than welcome to ask us questions.